I am going to teach you conductometry titration. We look into principle. Conductometry titration is a titration used to measure the amount of an analyte present in the given solution by measuring the change in the conductance as a function of volume of titrant. Here, the conductance is mainly due to the movement of ions in the solution. And here we do in the titration, we see that one ion replaces with another ion of different ionic conductivity during the titration, and equivalence point is determined graphically. Here we take an example of strong acid versus strong base, hydrochloric acid versus sodium hydroxide. Hydrochloric acid is taken as strong acid and sodium hydroxide is taken as strong base. That is, hydrochloric acid and sodium hydroxide both are strong electrolyte. That is, ionize immediately in solution. So we representing hydrochloric acid as H plus Cl minus as, and sodium hydroxide Na plus and OH minus. Here HCl is an analyte and sodium hydroxide is titrant, so that we are going to determine how much hydrochloric acid is present. So sodium hydroxide is titrant, which is fed into the burette. We can do it other way wrong also. If you want to determine sodium hydroxide, a sodium hydroxide added to hydrochloric acid solution, it forms sodium chloride, which is also strong electrolyte. So we representing there as ions which form water, which is non-ion. It does not contribute for any conductance. Here we see H plus and OH minus ion. For fast moving ion has high ionic conductivity, so it gives more conductance, and Cl minus and Na plus ions slow moving ion which has low ionic conductivity and which contribute for less conductance. See what is going to happen in the analyte solution during the titration. Before titration, only hydrochloric acid present. Presence of H plus with high ionic conductivity, high conductance. During titration till neutralization point, H plus with high ionic conductivity is replaced by Na plus with low ionic conductivity. Conductance decreases. Before the titration start, that is in beaker, we have only hydrochloric acid solution. 20 ml of hydrochloric solution, which is titrate against same molarity of sodium hydroxide. In the beginning, only hydrochloric acid is present. It present has H plus and Cl minus. We see that H plus ion have ionic conductivity, so the conductance value is very high. And we plot the graph here, and also we add sodium hydroxide, same molarity and same concentration. Here we see that hydrochloric acid has come down to unreacted hydrochloric acid is high ionic conductivity is replaced by slow moving Na plus ion which has low ionic conductivity. So this is going to continue till the equivalence point, that is a sodium hydroxide is continued added. We see that H plus ion is replaced by Na plus ion and the conductivity value continuously decrease up to neutralization point. This is what we have seen, got it. The conductance values decrease throughout the neutralization point. At the neutralization point, all the 20 ml of hydrochloric acid is reacted with 20 ml of sodium hydroxide because the concentration is same. Now at the neutralization point, we see that only sodium chloride is present as solution in water. So sodium chloride, both the Na plus and Cl minus ion have low ionic conductivity. So these are least conductance. All the values in the titration. Now added sodium hydroxide further. After all the hydrochloric acid is reacted with the sodium hydroxide, now add another 1 mol of sodium hydroxide Now we see that no hydrochloric acid is react with sodium hydroxide. So we have 1 ml of sodium hydroxide is accumulated in the analyte solution. So we have Na plus and OH minus ion. See that OH minus ion have high ionic conductivity. So the conductance point is increases. After the neutralization point, this keep adding sodium hydroxide, the conductance value increases after the neutralization point. Now we are going to plot the titrant value volume of sodium hydroxide against conductance. We see that conductance value decreases as fast moving H plus ion and substituted with the slow moving Na plus ion, and after the neutralization point we see that due to addition of sodium hydroxide, due to accumulation of OH minus ion which has high ionic conductivity, the conductance value increases. Now we draw the maximum number of points fall on the line, two lines meet. This point we take as volume of sodium hydroxide. This will be concordant value. At the neutralization point, sodium chloride and water are present. Least conductance. After neutralization point, excess sodium hydroxide is added. Accumulation of OH minus ion with high ionic conductivity, conductance increases. We take case of weak acid versus strong base, that is acetic acid versus sodium hydroxide. Acetic acid taken as weak acid and sodium hydroxide taken as strong base. Acetic acid is analyte taken in beaker, sodium hydroxide is titrant taken in burette. We need to understand few facts before we start the titration. Acetic acid is weak acid, does not dissociate easily. So we not representing as ions, where sodium hydroxide is strong electrolyte which dissociate immediately. So we can represent as Na plus and OH minus ion. As sodium hydroxide is added to acetic acid, we see that forms sodium acetate. CH3COONA dissociate better than acetic acid CH3COOH. So we can representing as again as ion, and we look at Na plus has low ionic conductivity, slow moving ion, so contribute less conductance value, and H plus and OH minus ion have high ionic conductivity. Before we start the titration, only acetic acid is present in the solution. Acetic acid does not dissociate easily, but it dissociates to some extent, so going to here low value. And as we add sodium hydroxide, initial addition of sodium hydroxide shows that some amount of acetic acid reacts with sodium hydroxide to form sodium acetate. Here we see that sodium acetate in right hand side and acetic acid in left hand side. Due to common ion effect, acetic acid does not dissociate easily and slight form in conductance. Now after we continued adding sodium hydroxide, that is during titration till the neutralization point, we see that sodium acetate is continuously forming as sodium hydroxide added to acetic acid. Here we already see sodium acetate ion is better than acetic acid. Conductance value slightly increases. At the neutralization point, all the sodium hydroxide reacts with the acetic acid. We have only sodium acetate and water, and here these two ions CH3COO minus ion and Na plus ion, here we see that conductance increases as in previous case. After the neutralization point, we see that we don't have acetic acid react with sodium hydroxide, but we still adding sodium hydroxide. So this accumulation of fast moving ions, that is OH minus ion with high ionic conductivity, so that drastic increase in conductance value after the neutralization point.